Hi, I'm actually in school today, Monday, but I thought this lesson might be a little easier to convey if I just pre-video it instead of having you guys have to try to follow it through the screen. So today's another technique on how to integrate stuff that we can integrate already. And the technique is called partial fractions. So it's a technique, it's actually all algebra based until we get to the end and then we can actually integrate our problem. But it's something that we use when we see a fraction, hence the word fractions, and when the bottom of the fraction can be factored. So let me start with saying if I had 2x over 3x squared minus 5, this would not be a partial fractions problem because this would be your regular substitution. I could let u equal 3x squared minus 5. And then du would be 6x dx. Sorry. And then I'd have my bottom to be a u, and my top isn't quite 6x, but if I multiply by a 3 and a 1/3, I'm all set. So this is a substitution problem that some people might look at after you know partial fractions and think partial fractions, but it's not. So if we have a fraction, and if I pick the bottom to be u, the du all works out, that's how you want to start. So whenever you have a fraction problem, you want to start with substitution. You don't want to go directly to partial fractions. Another kind of fraction problem that's not partial fractions is if you had a top that you could do long division with. So if you can long divide your bottom into your top, you want to do that. I have a yawn coming on, pardon me. It's that wellness day right now, and we just did an acupuncture class, so I'm feeling very relaxed. So if you can divide your bottom into your top, you want to do that. You want to use long division and do your problem that way. So this is not a partial fractions problem. So a partial fractions problem looks something like this. I'll try to make sure I stay within this box so you can see everything. Okay, so let's say you have this problem, and we try to let the bottom equal u. So if I were doing this from scratch, that's the first thing I would do, is I would let the bottom equal u. Don't write this down, P.S., spoiler alert. I would let the bottom equal u, and then the du is going to be 2x minus 2 with respect to x. Well, the trouble with that is, sorry, my son's texting me at the same time, and he's asking me for Halloween candy. Good Lord. The problem with this du is that I don't have this on top, and there's no way to manipulate 5x minus 3 to be 2x minus 2. There's nothing I can multiply by to get that substitution to work. Even if I could get the coefficients in front of the x's to be the same, I can't get the numbers by themselves to be the same. So this is not going to work with regular integration or with substitution. So I need a different way. So that different way is called partial fractions. And it actually takes a lot of paper, so I'm gonna probably have to make some steps and go back and forth. So when I do a problem and I start with setting the bottom equal to u and hoping that du is gonna work out on the top, and that doesn't work, I wanna stop and say, does my bottom factor? And if the bottom factors, that means this is a pretty good candidate for partial fractions. So if I look at this, does my bottom factor? Well, yeah, it does. This factors to x minus 3, x plus 1. So that's my first step to know, okay, this is a pretty good candidate for partial fractions. So what I'm going to attempt to do is I'm going to be attempting to take the factored version of this problem and get it split apart the denominator so that it's written as something over x minus 3 times something over x plus 1. This isn't going to make a whole lot of sense at first until you go through it once and then maybe a second time before it makes a whole lot of sense. But what I'm going to try to do is rewrite this fraction so that, I'm going to write this neater in a second, so that I have some number over x minus 3 plus some other number over x plus 1. So that if I'm able to rewrite this fraction as two simpler fractions, these are both easy to take the integral of. This is going to be a natural log, this is also going to be a natural log, and it's going to be pretty simple once I get to this point. The hard part is, how do I take this and rewrite it like this? We know really easily how to put fractions together, but it's not so hard to break them up. It's not so easy to break them apart. This is like saying, if I have like 3/11 plus 2/3. Oops, sorry, I have to keep doing this. I can easily add up those two fractions by creating a common denominator and fixing my tops. And adding my fractions. But what if I'm given 33s and I'm asked to break this back apart? What if I'm given 31 over 33 and asked, well, what would this be if I had something over 11 plus something over 3? Well, you could figure that out and maybe you would guess and test a bunch to get to the right thing. But this is what I'm being asked to do on a much more complicated level. I'm being given a fraction that's all put together as my original problem, and I'm being asked to take it and split it apart. So I'm being asked to take that whole fraction and split it apart into two pieces. So to do that, let's say you didn't have calculus, you had this. If I wanted to figure out what the two numerators were so that these two fractions would add up to 31 over 33, maybe I'd multiply both sides by 33 and I would do some maybe guessing and testing to figure out what it could be. Well, we don't want to guess and test. That's kind of silly. So there is a whole strategy to figure out how to get this big factored form into two separate factors. So it goes like this. Because I'm going to keep running out of room, I'm going to erase the top and move this over. So I'm going to try to take this factored bottom and figure out, let me just take this integral symbol away for a second, and let's just try to take this fraction and figure out what would this be if I split it up. If I had x minus 3 on the bottom of one fraction and x plus 1 on the bottom of another fraction. And I'm going to use A to represent the top of this and B to represent the top of this. And A and B are going to end up both being numbers. Okay, they're actually not even going to be variable terms. They're going to both be numbers. So, this is a huge algebra problem. How the heck do we solve this? Well, if it's algebra, the first thing I'd want to do is multiply both sides by that least common multiple, by the thing that will make both denominators cancel out. So I'm going to multiply both sides of this whole mess by x minus 3 times x plus 1. Hopefully we can still see if I'm that far away. I'll move myself back in a second. Okay, I'm going to multiply both sides of this fraction by x minus 3x plus 1. I'm going to also turn the one light off so the glare goes away, hopefully. Not great, but a little bit better. Oh my God, it's still there. Ah! I'm closing the shades, but I don't know if it's helping. No, it didn't help. Maybe I should just teach from a cave and that would be better. Okay, so we're going to multiply both sides by this denominator. And what's it going to do? On the left, it's going to cancel completely with the denominator, and I'm going to be left with 5x minus 3. On the other side, when I multiply both of those fractions by that big expression, when I multiply this to this fraction, the x minus 3's will cancel, and I'll be left with a times x plus 1. When I take the whole thing and multiply it by the second fraction, the x plus 1's will cancel, and I'll have left b times x minus 3. Okay, so now I have this huge algebraic expression that I'm going to try to figure out what a and b are. Because if I can figure out what a and b are, then I know what the tops are, and I know then how this big fraction simplifies or gets broken apart into these two smaller fractions. So I'm going to distribute. So I'm going to have 5x plus 3, minus 3 equals ax plus a plus bx minus 3b. Okay, agreed? Now, what the heck do I do with this mess? Well, I want to think on the left side, I have an x term and I have a numeric term. So I have a 5x and I have a plus negative 3. On the right, I'm going to group this up as well. I have two terms with x's. I'm going to group them up and I'm going to pull the x out to the front of them. So take a second and see what I did. I'm trying to stand in the glare. I'm taking the ax and the bx. I'm just moving them around so they're next to each other, and I'm pulling the x out of them. And I'm making this x times a plus b. Plus, I have an a and a minus 3b. Group that up together. So how is that helpful? Well, if I look at the left, and the left side has to equal the right, and this is the term with x, and this is the term with an x, I know then that 5 has to equal a plus b. For this equation to work out, this 5 is the coefficient of x. A plus b is the coefficient of x on this side. So a plus b must work out to be 5. Likewise, negative 3 is the number without an x. This is the number without an x. So negative 3 must equal a minus 3b. Well, if those two things have to be true, I just created a little systems of equations that I can solve. 2 equations, 2 variables. I got it, no problem. Right now, I'm going to add the 2 equations together, but I don't have matching coefficients with opposite signs. So I'm going to multiply this equation by a negative 1. So I get a positive 3, a negative a, and a plus 3b. Put this together, 5 plus 3 is 8. A minus a is 0. B plus 3b is 4b. So b must equal 2. If b equals 2, what is a? If b is 2, a must be 3. Well, I just found it. I just took that huge mess at the top, and I just figured out what a and b are. So all that work, try to think about uncanceling this, because I want to go back to my original. I just found out that a is 3 and b is 2. This is dead. I made that basket. So what did I just do? So what I did was I took my original equation, or my original integral, that was 5x minus 3 over x minus 3, x plus 1, because that's my factored version. I just figured out that this is the same thing as the integral of 3 over x minus 3 plus the integral of 2 over x plus 1. That's what I just did. I just made my crazy integral that I couldn't do simplify into into 2 much easier ones that I can do. I'm trying to block that. So I can do these 2 separately. Remember, these guys are just multipliers. Put them out front if it makes you more comfortable. I should have a dx here and a dx here. So over here I get 3 times, what's the integral of 1 over x minus 3? The natural log of the absolute value of x minus 3. Plus 2 over here, natural log, absolute value of x plus 1 plus c. Whoa, I just did it. So this is the answer. This is the antiderivative of this original function. Well, remember, we hate checking because it takes time and it's annoying. But if I wanted to check it, I could take the derivative. The derivative of this term will be 3 times, the derivative of natural logs has put this on the bottom, the derivative of this on the top, plus over here I have 2 times, put this on the bottom, derivative of that on the top. So there I go, I've got 3 over x minus 3 plus 2 over x plus 1. And if I wanted to put that all together, I could get a common denominator. My denominator would be x minus 3, x plus 1. On the top, I'd have 3 times x plus 1, plus 2 times x minus 3. And if I went and simplified all that, I'd have 3x plus 2x, so I'd have 5x. And I'd have 3 minus 6, so minus 3. Over, put that all together, x squared, minus 2x minus 3. So if I take my answer and take the derivative of it and put it all back together, I get back to the original. That's partial fractions. So each one takes a lot of page, and it's actually pretty easy, but if you don't really pay attention to each step, you're going to be like, what is she doing? How does she get from one step to the next? So let's do one more. Okay, it's just, this is one of those where you repeat the steps enough times, you get it. It just makes sense. If you don't repeat the steps enough times, then it feels really confusing because you feel really lost. All right, so let's do this one. Let's do one where there's no x on the top. So let's do the integral of dx over x squared plus 2x plus 3. Sorry, that looks really similar to the one that we just finished. Oh, minus 3. It looks really similar to the one we just finished, but that's okay. It's going to be different. Okay, so you might want to like start this next step and then pause and come back, start and pause and come back and see if your works matches mine. So the first thing I'm going to do is I would try substitution, but I know if I pick u to be the bottom, there's no x on the top at all, and my du is going to have a 2x, so I can't use that. I can't long divide top into or bottom into top. I don't even have enough powers on the top to do that, so I'm going to have to go partial fractions. So this is going to be x minus 1, x plus 3 over 1, and I want to figure out what number do I put over x minus 1, and what number do I put over x plus 3? So this is the algebra I'm trying to work out, so I can go back and replace the original with what it is, or with the new way of writing it. So I'm going to multiply both sides by x minus 1, x plus 3. Over here, I'm going to get 1 equals a times the remaining factor plus b times the remaining factor. I'm going to distribute and group up my x's and my non-x terms. Okay, this is different than the last one because the only thing I have on the left is 1. So what am I supposed to match up the x term with? Well, technically, I have a 0x plus 1 over there. So I do have something to match up my x term with. So the coefficient of x on the left is 0. The coefficient of x on the right is a plus b. The 1 on the left is going to equal the 3a minus b. Oops. Okay, so let's add these together. I'm going to have 1 equals 4a. So a equals 1/4. B then equals negative 1/4. So let me show you what I do when I get my a and b to be fractions. When I go back up to the top, and I rewrite this, I'm going to take my fraction out immediately. So since a is 1/4, I'm going to write this as 1/4 times the integral of 1 over x minus 1. And this is minus 1/4 times the integral of 1 over x plus 3. Okay, I'm going to take that coefficient out right away. I just feel like putting a 1/4 on top of this feels confusing. Putting a negative 1/4 on top of that feels a little confusing. So I'm just going to take those coefficients out to the front before I even start on the integration. So I'm going to go, this is 1/4 times the natural log of x minus 1 minus 1/4 times the natural log of x plus 3 plus c. And you would think I'm finished, but there's a trick. So this is finished. There's nothing wrong with it. But if you were taking a multiple choice test, they wouldn't leave the answer this way. They would use a log rule to simplify this a little bit. And that log rule is, do you remember over here? So the natural log of a, b can be written as the natural log of a plus the natural log of b. If I have two logs added, I can write them as multiplication. And if I have the natural log of a over b, this is the same thing as the natural log of a minus the natural log of b. It's a little log recap. So what I have over here is I have the subtraction of two logs. I can write that as one log with division. So I can come back here, and since the coefficients of this are the same, I can take the 1/4 out and be left with the natural log of this minus this. So that's going to be x minus 1 over x plus 3. Plus c. Actually, I don't really need these brackets, do I? That's how you would see that answer. Lucky you. Okay, if you need to watch it again, and then you just need to practice. So in your textbook on page 549, I want you to try two of them, number 5 and number 8, and I'll have the answers posted. And tomorrow we might just try 1 or 2 more as like a Khan Academy to make sure you feel okay. All right, hope you had a good weekend. Talk to you later. Bye.